Greetings, my name is Diego Luna, a 10th grade student, and together with my classmate Lito Porto and on behalf of the Biontessori Research Group from the Montessori School of Cartagena, we present the project Land Cover and the Diversity of Bird Communities in Mangrove Forest Relics in the vicinity of the Siena de la Virgen and Juan Polo, north of the district of Cartagena, Indias, during the rainy season of the year, period 2013-2020.
Our investigative unit is made up of 8 students and 2 teacher co-researchers, Juan Felipe Restrepo Mesa and Catherine Belandia Ricardo.
Our project is located in the Colombia Caribbean region, to the north of the district of Cartagena, between the corregimientos of La Vaquilla, Manzanillo del Mar, Tierra Baja, and Puerto Rey, in the vicinity of Siena la Virgen and Juan Polo, and the Ciénaga del Totumo, corregimiento of Lomita Arena. The Siena la Virgen is the second most important wetland in the Colombian Caribbean region. Unfortunately, one of the most affected by the felling of mangrove swamps, the lack of recirculation of seawater, illegal invasions, chaotic and excessive urbanism, and works recently executed. As the same investigative unit pointed out in 2018 in the report Ondas Bioexpedition to the Dry Forest Mangrove Forest Ecotone, research work that represented Colombia at the Mostratec International Fair in 2019.
Authors such as Alferin and collaborators cited by Gomez Rodriguez manifest the use of land is linked to different human activities, which are conditioned by biophysical and socioeconomic factors. These uses modifies ecological processes and determines terrestrial ecosystems biodiversity patterns.
Acuña and his partners in the Guide for the Ondas Bioexpedition Group's Biontessori site in the Humboldt Institute proposes, amongst others, the 2 methods to measure diversity. The first one being alpha diversity, or the number of species at local scale, with the indices of Margalef and Shannon. The first one is the ratio between the number of species and the natural logarithm of the number of individuals. The second is the sum of probabilities of finding a particular species in the environmental unit under study. The second method, or beta diversity, is the replacement rate for the species composition between different communities, habitats, or regions. In this project, we use Sorensen, Jacquard, and Bray-Curtis indices as dissimilarity indicators.
Other resources used by this investigative unit to compare land cover with diversity were the so-called vegetation indices, the normalized difference, and the modified triangular index. The first allow us to determine the state of health of a forest ecosystem by contrasting the portion of reflected light against the infrared nearby absorbed. The modified triangular index looks like the previous one. Still, it differs from this in that its value is independent of the index of the leaf area, ideal for measuring primary productivity in a body of water. These indices fluctuate between 1 and -1, being 1 a very healthy forest and -1 being a heavily intervened or affected forest. On the other hand, we have the infrared, which shows us the reflection of the wavelength of the electromagnetic spectrum greater than 700 nanometers. These estimates can be obtained from Landsat 8 satellite images hosted in the United States Geological Survey (USGS) reservoirs and on the Planet.com app.
All of the above led us to formulate the following research question. What is the relationship between the land cover and the diversity expressed as a function of richness and abundance of bird communities in mangrove forest relics north of the district of Cartagena, Indias, in the vicinity of the Siena la Virgen and Juan Polo during the rainy season of the year, period 2013-2021?
To answer the research question, we follow a 3-phase methodological route. The first phase, called planning, the second phase, called research development, and the third, precisely where we are at this moment, called communication of results.
The analysis of the bird communities, the dataset of the endotropical census of aquatic birds corresponding to the period 2013 and 2020 was taken into account. Additionally, bird counts were carried out in the Siena la Virgen and El Totumo in August 2021, coinciding with the date of the sampling carried out in 2019 by this same investigative unit in the stations Bajo Aves, Bajo Mesa, and Juan Polo Lagoon. These correspond to the second rainy season of the year, As a control, sampling was conducted in the Ciénaga del Totumo in the south, south, and north stations. The sampling protocol of stationary points and fixed radius proposed by de Graaf and cited by Mels, Glens, and Martin. For the taking of the physical-chemical parameters of dissolved oxygen, salinity, temperature, and transparency, the protocols of the NASA GLOB program were applied. It should be noted that this investigative unit has access to the original dataset by taking part of the Neotropical Census of Water Birds.
From the dataset of the Neotropical Census of water birds from the period 2013-2021 and the data from the output of August 2019 and 2021, the diversities of Margalef and Shannon were calculated. As can be seen in Figure 4a, there is a deterioration of these indices over time. The rebound in 2021 is explained by the increase in species of land birds that have been replacing some of the aquatic species that have stopped visiting the wetland, such as the American oystercatcher, Amadeus clote, of which there is no record since 2013. In the Figure 4c, the Sorensen Similarity Index for the Ciénaga de la Virgen is observed, which show us year by year it becomes more different than the year 2013, taken as a base. In the Figure 4c, the Margalef index is plotted for two functional groups of birds, waders and the wading birds, bioindicators of the health status of a wetland as pointed out by Sanchez in 2016. A very important finding emerged from this figure: the important increase in the diversities of these groups of birds in 2017.
Based on the natural color satellite images taken from Google Earth and Asset A for 2017, a transcendental fact is observed that explains that increase in the diversity of waders and wading birds, the opening of a natural mouth north of the Ciénaga de la Virgen. Additionally, in the lower right image, the index of modified triangular vegetation tracks the flow of water that carries phytoplankton, increasing the primary productivity of the Ciénaga. However, in the same image, a pocket of low purple productivity is observed to the northeast as a consequence of a residual current, which demonstrates the need to open an additional mouth to the north of the Ciénaga de la Virgen and Juan Polo to increase the circulation of ocean water. Returning to the natural color image, the areas of two polygons were calculated: in green the mangrove forest, and in yellow the area illegally logged due to invasions. See black and red arrows, estimating a loss of almost 40 hectares, which is equivalent to the 16% of the original forest area in those polygons. It can also be seen in the upper right image that change in color, the normalized difference vegetation index between the original areas, intense yellow color, and the devastated areas, green color. See red arrows.
This investigative unit consulted the daily rainfall data for the period 2013-2020 in the IDEAM. See Figure 3, corroborating that the 3 years 2013, 2016, and 2017 were the rainiest in the series, with over 1,000, 7,000, and 3,000 milliliters of water per year, respectively. This meteorological finding explains the cause of the natural mouth opening.
Besides, wetlands are sensitive to exogenous factors such as La Ciénaga del Totumo for the years 2020 and 2019. Contributions of organic matter from the manure of cattle generate punctual increases in the primary productivity of the lower left image, generating a decrease in the transparency of the water and increases in the concentration of dissolved oxygen. To demonstrate the relationship between land cover measured in terms of red and infrared reflectance and the diversity of bird communities, we proceed to establish 7 sampling stations with 18 30 by 30 meter plots, 9 on dry land and 9 on water, as shown in image number 3. These stations were Los Arriberos Deck, Bajo Aves, Bajo Mesa, Juan Polo, Puerto Rey, Dos Puntas, and Bocana. Additionally, for the part of the physical-chemical parameters, the data from Station 8 of Cartique were taken as reference for the period 2013-2021. Asset 8 images were downloaded for the study area, period 2013-2021. Using the ArcGIS Pro program, the NDVI values were extracted, and the MTVI2 was calculated for all of the 126 quadrants during 2013 and 2021. Those of each year were averaged, obtaining a single value per year for the NDVI and MTVI2, terrestrial, aquatic, and total. Table 1.
Bray-Curtis and Jaccard dissimilarity indices were calculated among all the series years. Figure 10 shows that the pair 2013 with 2020, 2017, and 2019 are further dissimilar to the entire series. Additionally, the Pearson Correlation Index was calculated between the diversities of waders and wading birds with the NDVI and the MTVI2, terrestrial, aquatic, and total. Notice as the highest correlation index, 0.66 positive, occurs between the diversity of shorebirds and the terrestrial NDVI. Likewise, between waders and total NDVI, 40.44 positive. MTVI2, terrestrial, 0.37 positive, and total MTVI2, 0.40 positive, respectively. On the other hand, in a principal components analysis for the waders, year 5 of the series 2017 is the most different from others, and in a principal coordinates analysis between the variables Markov diversity of waders, the NDVI terrestrial, dissolved oxygen, and salinity, it is observed that the variance in 89.9% depends on the diversity and the index of vegetation of normalized diversity, and show us as these variables behave inversely with salinity and with dissolved oxygen. This explains the severe impact that the lack of recirculation has in the Ciénaga de la Virgen and Juan Polo. As the temperature rises, evaporation increases, consequently increasing salinity and paralleling a drop in dissolved oxygen. But what is even more severe is the impact that deforestation and the legal occupation of these properties have on diversity, in this case, bird communities, as demonstrated by all these data.
Conclusions of this work, it can be stated that it was possible to answer the research question by demonstrating that changes in land use and land cover entail changes in the diversity of bird communities, particularly those aquatic functional groups with high levels of adaptation sensitive to the food supply. Land cover, NDVI indices, and NTVI2 and the diversity indices of birds in the study area have deteriorated throughout the study period 2013-2020 for the second rainy season of the year. The deterioration of the mangrove forest and the change in land use have direct consequences on the climate change and dramatic increase in the impact of natural phenomena such as wind, waves, tsunamis, hurricanes, floods, erosion, amongst others. Understanding and reversing this deforestation will allow communities around the swamps to use the ecosystem to adapt and mitigate the effects of the climate change. Opening new mouths to the Ciénaga de la Virgen in its northern part would allow the entry of water with beneficial effects at the wetland, and with this on the climate change, a decrease in water temperature and increasing dissolved oxygen concentration and the salinity regulation giving to mangrove forests better conditions for its optimal growth, which in return would imply a more significant sequestration of carbon dioxide, reducing the concentration of this greenhouse gas. These new narratives, the so-called story maps based on geographic information systems and big data, added to the use of birds as bioindicators, are extremely useful in understanding the problems afflicting the ecosystems associated with the Bay of Cartagena, its streams, lagoons, and swamps. Regarding the recommended steps and anticipated outcome for this project, for the next phase of this research group intends to complement these findings with the processing of large volumes of data stored in data repository information, the so-called big data. In such a way, said information is analyzed, processed, and visualized so that all the phenomena associated with biological communities and ecosystems can be understood even more deeply. This investigative unit thanks GLOB, NASA, and the USGS for allowing access to the resources such as Landsat images and the training received in the Trees Around Globe campaign to professors Milton Guerrero and Andy Dominguez from the UTV, who trained us in using advanced tools of Google Earth ARGIS, and multivariate statistical analysis. Also to the Association Calidris for its inspiration and for giving us access to the data of the Neotropical Bird Census.
We hope that this study promotes critical reflection on the role that we must play as citizens, as watchers, and the authorities and leaders of our city in the exercise of their functions, to fulfill the mandate that was granted to them and that is enshrined in the national constitutional of the law. Mangrove forests are worth protection.
On behalf of the Biontessori group of the Montessori School of Cartagena, a very special thanks to the UTV, Cardique, Calidris, Ondas Bolivar, the Gold Program, Los Arriberos, and to the fishermen of the Ciénaga del Totumo, to NASA, to our parents, to our co-investigator teachers, to all, thank you very much.
Our bibliography. Credits. On behalf of the Biontessori group, thank you for your kind attention.